As promised, here is the second one of those problems that I had told you that we will do. And this is another acceleration problem. Slightly different setup, so that means we will probably do something slightly different to solve the problem. So why don't we go through it, find out all the pieces, write them down in our list on the left, find out what equation or equations will work for us, and then we should be done. This is a one-step problem, by the way. Hard to see unless you've done it a million times, but just so you know, it's not like an 8-step problem or something. It's okay. We're going to get it done in one. A cat burglar is traveling at, I'm going to underline stuff, 700 meters per second and comes to rest. That seems important. At an acceleration of negative 30 meters per second squared. Over what distance does the cat burglar travel? All right, so we've got plenty of information here. Plenty of stuff to work with. So let's find out what we got. Is traveling at 700 meters per second. First off, that's about twice the speed of sound. Okay, now with that out of the way, it is twice. Is that right? Yeah, it's twice. That's crazy. You're going Mach 2 over, what is that, 1,000 miles an hour? No, something like 1,400 miles an hour. Okay, great. Anyway, 700 meters per second, very fast, is traveling at. So that implies that that's where we're starting. This is where we begin. So that means that our initial speed is 700 meters per second. Next, and comes to rest. Actually, I should have underlined the word comes as well. Comes to rest. Okay, well, that means that we are going to be going to a restful state. So it's coming at some speed, and then it goes, stops. Okay, so it comes to rest. That means that our final speed is going to have to be 0 here. It comes to rest. That is how fast it's going in the end. Now, at an acceleration of, this should be obvious based on that phrase there, negative 30 meters per second squared. The only thing that has an A in it, 30 meters per second squared. Okay, now, over what distance does the cat burglar travel? That is implying something with the x's. Now, over what distance does the cat burglar travel? I'm going to assume that that's probably going to be xf, question mark, right there. Okay. Now, x initial, this is one that unless you are given it, you can automatically assume something about it, okay? This is one of those ones where you just kind of set your coordinate plane right at where the problem begins, okay? So that means that we're going to start off at 0. We're going to make this problem easy on us, okay? We don't know where it ends, but we know it starts somewhere, and we're going to call that 0. All right, now, you'll notice there is no mention of time anywhere at all in this problem, so this is also an unknown. Now, once again, we have all the crap written down, what we have. So now it's a matter of finding out which equation we need to use. So we are looking for x final. This is what our goal is right here. Okay, so that implies that anything that omits x in any way is not useful to us. This first equation, for instance, there's no mention of x at all, so we don't care about it. We're not going to use that one. All right, the second one, does it show x? Absolutely. So we might need to use that one, and this one also mentions x there at the end. Okay, so either one of these currently is what we have. Now, let's look through these equations and see if we have all the information to solve for x. Okay, we need this. X initial, we have that. V initial, we got that. Time. Red flags everywhere. Oh my gosh, they're coming for us. We don't have this. We don't have time. We look back at our little list. We don't know how long this took. Okay, it took an amount of time, certainly, but we don't know what it is. So it looks like this second equation is also useless to us. This is an equation that has two unknowns, x final and time. And also, it's crazy because this has two time terms, so we'd be double screwed if we tried to use this one. Could you do it? Probably, I don't know. No, actually, now that I think about it, you can't. With just this, you can't. You'd have to shove these two equations together. Okay, and you could do that, by the way. Neither here nor there. Actually, that is here because that's what this is. So let's take a look at this last one. Does this have all the pieces? Final speed, we have that. Initial speed, we have that. Acceleration, indeed. X final, what we're looking for. X initial, we have that. Okay, so it looks as though this is the guy. There it is. That's our buddy here. So why don't we plug all of these numbers into this equation, and we will find our final position. Okay, so V final is our first number, and that is 0. So 0 squared is 0. I won't write that because that's silly. V initial is 700 meters per second, and we're going to square that number. You might say to yourself, that's going to be big. You're right. Good job. Now, 2 times a negative 30 meters per second squared. This means we're slowing down, right? Negative means that we're going in the opposite direction of motion. Okay, cool. Now we've got x final. That's what we're looking for. So we just write the variable minus 0. Okay. Now, if you guys recall, if you have anything like this inside of a parentheses, that can just go away. I'm going to go ahead and do that right now. And I'm just going to rewrite this parenthesis like this. Okay, anything minus 0 is just the thing itself, right? In mathematics, you can do that. It's legal. Now, what we're going to do is we're going to do some numbers. I hope you can do the second part of this by your lonesome. It's taking my calculator a little while to work here. 700 squared. Okay, 700 times itself is a big old number. Equals 490,000. Oh yeah, of course it is. And well, you're going Mach 2. Okay, you're going to be going pretty quick. Okay. Meters squared per second squared. Okay, I squared the units because that makes sense, right? You square everything inside the parentheses. Next, plus 2 times negative 30. You can do that in your head. That's going to be negative 60 meters per second squared. Okay, times x final. Now, this is a matter of simple algebra. You move some crap around, you do some division. Okay, so I'm going to move this term to the left. I'm going to add it, add to both sides. Add 60 meters. So I didn't write all the steps last time because I was running out of space, but I think I have just enough space for right now at this step. Times xf. Thank you. Now we're sitting at, I'll write it over here, 60 m over s squared xf equals 490,000 meters squared per second. I wrote this problem. It's my own dang fault. Divided by 60, you get x by itself. That's what you're looking for. Divide by 60 meters per second squared. That's silly. Anyway, all your units are going to cancel. The squareds will cancel. And right there you're left with just meters, which is encouraging because you're looking for a position in the end. So now we're going to take 490,000, divide that by 60. I'm not going to make it too much smaller. So xf equals 8,166.7 meters. Okay, usually around to the hundreds, but when you're having such a big number, it doesn't even matter. Okay, there we have it. So, for this problem, once again, what we did was we found the necessary bits. There they are, there they are, there they are, there they are. We find out where those belong inside of here. We use our units. We use our context clues, like comes to rest, makes it 0. We use the assuming that initial position is 0. And then we looked through the equations to find which made the most sense concerning what we have. Once again, we don't have time, so it just actually completely destroys these first two. Okay, we don't have it, and we're not looking for anything in these equations. Well, except for that one. So we can't use them. Okay, we can't use those first two. So we look for something that has all the crap that we have, and that's this guy. Okay, so once again, this is about 9-minute long video. Remember, this is explaining stuff, intermediary steps, right? And I'm saying all the crap as it's happening. If you're doing it by yourself, it's going to take less time. Yes, once again, there's a lot of stuff going on this piece of paper. The main segments I want you to have on your paper, though, this whole big thing here, okay? That's super useful. You write out all the stuff that you have and all the stuff you need, okay? And you don't have to write this on every paper, but have it handy so that you know what you're working with, okay? Very important to have this stuff handy. Eventually, you'll memorize them on accident, and then you'll memorize them on purpose. Well, is that right? I can't remember. I memorized it on accident. Just because you use it enough, you memorize it. Okay, and you'll know which one to use in certain situations. You use this one when you don't have x. You use this one when you don't have final velocity, and you use this one when you don't have time. That's what we did in this scenario. So good luck, have fun. I will see you guys on Tuesday.